I'd like to share with you some of my research that I've been undertaking into the instances of Aurora, both past and present, particularly in East Anglia, but also across the rest of the country. This talk will take the form of my research into the 19th century Aurora observations, and then I'll go on to talk about a little bit about the theory and myth that presented itself in the press and publications of the time, then a little bit about the science, and then come right up to date with Steve and his mates, discuss whether this really is a new phenomena. So why bother with historical accounts? This normally gives us an idea or ideas for new research, or perhaps we're looking for previous events to support current theories. Particularly if we're looking at the sun and solar activity, we often look for previous evidence for long period cycles and long timeline astrometrics. For example, the use of the Lowell Observatory photographs of Pluto around the 1930s that helped to plot the orbit of Pluto more exactly to enable the New Horizons spacecraft to pass within a few thousand miles successfully a few years ago. So that was a very successful use of historic data. Or, of course, just for plain interest. Now, my research concentrated on the 19th century, as references prior to that were very few and far between. So the reference sources I used were the British Newspaper Archive, the Society for the History of Astronomy County Archive, the Ipswich Journal, 1835 to 1875. And unfortunately, that journal was only available online for those dates at the British Library. So again, that rather limited the research sources that I had. And various other Wikipedia entries for specific events. The main source was the English Mechanic, 1866 to 1898, a rather marvellous, typical English publication for gentlemen on all sorts of matters, scientific and otherwise. And of course, the local East Anglian Daily Times archive. So what did I search for? Well, I used the two search terms, Aurora and Northern Lights. Now, the Ipswich Journal came up with more than 100 references. The English Mechanic, which has a really nice built-in search engine, where it did in the DVD copies that are very kindly loaned to me by Bill Barton. And this turned up over 60 references. Now, the English Mechanic references ranged more widely than just East Anglia, including reports of Aurora from abroad. So I tended to discount the ones that are further afield from the UK. So you have to be careful. The term Aurora, of course, is used much more than just the term for the Northern Lights, particularly the poetical term used in prose and poetry to depict, for example, the sun's rays at dawn, as in the quote, "to see Aurora's charms at dawn." So this search did throw up quite a number of poetical references. But also there was a lot of references made to various boats and ships, variously named Aurora or containing the term Aurora in their name, including some nefarious references to bogus insurance claims, one in particular, when such a craft was lost, in inverted commas, at sea. You do have to be careful not to chase down rabbit holes when you're doing this type of research, because you can spend hours or weeks chasing down things that are not at all what you're really looking for. So some references were quite oblique. For example, several journal items referred to the London Fire Brigade and how they were kept busy being called out on false alarms by people raising the alarm because they confused bright aurora with real fires. But the research task was made quite a bit easier by the vying of two very keen weather observers, both based in and around Ipswich, each trying to outdo one another by providing weather reports for the preceding month and forecasts for the coming weeks, and as it says, often annotated with poetry. So obviously meteorologists with a hidden poetry bent. So the first of this was Orlando Whistlecraft. He lived in just outside Ipswich, village of Thwaite in North Suffolk. And all this started as a very polite letter to the editor in the English Mechanic and ended up as a long, very long column with a day-by-day scientific account on a monthly basis. And he too added an awful lot of poetry in his columns. So we can see there his grave at Thwaite, weather prophet, I like that term, and poet. The other of these two was W.H.B. Webster, who was an Antarctic scientist, according to his biography. And he lived various places in Ipswich, so definitely a local lad. And if anything, he was more poetic than Whistlecraft. And he did try to introduce cycles or repeating patterns into his forecasts, typically for rain and sunshine. However, he did extend this to his auroral observations as well. But from the correspondence that I've seen, he only appeared to look year for year on year patterns rather than longer cycles. So perhaps he missed finding the 11-year pattern by not going far enough. We don't know, but there we go. But I was surprised to see the number of observations of the aurora in all of these sources or these papers. And I can only assume that the sight of the aurora was something that was a wonder to behold, even though they didn't understand what it was. So because it was so awe-inspiring, it was worthy of so many column inches in print. And of course, the lack of light pollution in the 19th century would have enabled even low levels of aurora to be seen clearly. So it's also interesting to see the so-called experts who incidentally tended to be former military or naval men. So obviously they knew what they were talking about. And they were either writing in these papers or giving lectures on the causes of the aurora. And the most common explanation of the aurora was that it was sunlight reflecting from the polar ice caps down to these lower latitudes. That was a very common thought at the time, certainly in the mid-century. And one article in 1882 mentioned a particularly large sunspot group seen on the sun. And they noted that there was also a particularly magnificent aurora that night. However, they didn't think of linking the two phenomena together, which is a bit of a shame. So causality. So the first causality debates occurred in the English Mechanic around 1868 with an A. Dawson published an article called The Theories of the Solar Process. And then there were a number of reports in the latter half of the century making links between rapid changes in the Earth's magnetic field and the appearance of the aurora, and often citing data from the Magnetic Observatory at Kew. So the current thinking of the formation of the aurora was presented in a lecture to a large audience in Ipswich on Friday, February the 19th, 1875, by none other than our own John Isaac Plummer, who was the employed observer or astronomer at the Orwell Park Observatory. And the Carrington event of September the 2nd, 1859, was also widely reported around the world. It was not specifically mentioned in the Ipswich Journal, which was very strange, although the heightened aurora activity during September and October, because of the Carrington event, were subject of several letters. So what was the Carrington event? Well, the Carrington event was a solar superstorm that caused a major geomagnetic storm and auroral activity visible really as far south as the south of England and south of Europe. named after the astronomer Richard Carrington, who reported seeing a visible flare coming from the sun at that time. Now, as you can see from his dates, he was, what, 49 when he died? Does that man look like 49? I'm not totally convinced. That is the photograph of the man, but that is the one that's all over the internet, Cambridge University site and all the rest of it. But there we go. So obviously he had rather too much sun in his day, perhaps. So there was more debate within the columns of the English Mechanic. 3 or 4 parties, each had their own view of the nature of the aurora. And one W.T. Lynn of the Royal Observatory published a treatise on the periodicity of sunspots and aurora. And so hopefully this should put the debate to rest. Of course it didn't. So from then, debate turned to the atmosphere and what was the actual physical process that caused the aurora, what created the aurora. And debate such as what height the phenomena was produced and whether the aurora was accompanied by sound or not. And that sound debate carries on today, of course. One correspondent estimated that the auroral height was from several to 100 miles. Oh, I like that. Very scientific, from several to 100 miles. Several more correspondents proposed and described balloon ascents up into the atmosphere during aurora to investigate. And one such ascent, the aeronaut described hearing a loud noise. I'm sure it was the wind, and the smell of brimstone or sulfur. I think that was a case of more wanting to smell these things rather than actually smelling them. But there we go, don't know. All we can do is what was reported. For several months, the articles concentrated on reporting the colour and appearance and the structure. However, at the end of the 1872, the old chestnut of linking the aurora to weather and earthquakes reared its head again. And also there was another final gasp, as I call it, of the reflection of sunlight from the polar ice fields theory in one dear old retired naval captain, once again, put it in a letter. But it was at this point, around the second half or third, if you like, of the 19th century, that the scientists started to wade in. And over this time, experiments were reported about observations of the spectrum of the aurora, most notably in 1869 by a paper from the famous J.A. Angstrom on the spectra of aurora. And there was also an interesting report in the English Mechanic about new theories of solar light, heat, and actinism by one T.B. Barkas, which discussed auroral radiation around the sun, namely, as we know it today, as the corona. So a spectroscopic link between the aurora and the solar halo was reported again in an 1898 article, suggesting that this was the discovery of a new element within the sun called coronium. And this was first put forward by Grunewald in 1887. We now know, of course, that coronium was actually a spectroscopic line of iron. And the nicest snippet, though, I came across was from a US telegraphist who calculated that the energy contained within the aurora, and he claimed that it would be greater than 32 times 10 to the 6 horsepower per cubic mile of space. And I love those good old pre-SI units. Just like the old acceleration due to gravity on Earth is 7.1 times 10 to the 10 furlongs per fortnight squared. There we go. Right, so this is drawing together all the reports I found and the dates for the 19th century. In the upper graph, we've got the in blue the Ipswich Journal, and in red the English Mechanic data. And then afterwards, I had a look at another source called the Astronomical Register, and that's the number of sources at the bottom. So As you can see, there is a periodicity. Now, if we overlay the corresponding sunspot cycles, you can see that there is very strong concurrence there between press cuttings and i.e. the observance of the aurora and when it was occurring and the sunspots were reaching maximum. So that was the research bit. Now, looking back into the past, the theory and the myth of the aurora. The aurora was first described by the Greek explorer Pytheas in the 4th century BC. And then Seneca wrote about aurora in his first book, Natural Questions. And he came up with such terms as Pythei, barrel-like, and chasmata, Pagonii, Cyparissae. I'm going to stop that in now. And he talked about their manifold colours. And he also wondered whether they're above or below the clouds. So the debate, all those 23 centuries later, as to the height of the aurora. I find that sort of thing very interesting. Pliny the Elder, of course, waded in, and he may have depicted the aurora in his Natural History when he refers to falling red flames and daylight in the night. Japanese folklore. Pheasants were considered messengers for heaven. So they, in some of their reports, they suggested that red pheasants' tails were witnessed across the night sky over Japan in this case 620 AD. And that could have been a red aurora produced during a magnetic storm. And then we have the various Aboriginal Australians, and they associated auroras, which were obviously mainly low on the horizon, and we'll be looking at Aurora Australis, of course, there. And they were always associated with fire. And the various peoples, the Gunditj Mara people of Western Victoria, they called them ashes. And the Gunai people perceived them as bushfires in the spirit world. And so it went on, all to do with fires, evil spirits creating large fires, campfires of spirits in the land of the dead, and so on and so on and so on. 19th century Norse mythology refers to the armor of the Valkyrie, which sheds a strange flickering light which flashes up over the northern skies. And that made what men call the Aurora Borealis or Northern Lights. So that was a later work on Norse mythology. The first Old Norse account of the Nordlius is found in Norwegian chronicle King Saga. I'm not going to try and pronounce it. From AD 1230. The chronicler had heard about the phenomenon and from his compatriots returning from exploring Greenland. And he gives in this chronicle 3 possible explanations: that the ocean was surrounded by vast fires, that the sun flares could reach around the world to its night side, and that glaciers could store energy so that they eventually became fluorescent. This is getting dangerously close to the polar reflections again theory. So what does the aurora look like? I'm sure most people listening to this have seen the aurora. Many types of structure, rays, bands, arcs, 3 basic colors, green, red, and a violety purple. And thanks to the Sky at Night magazine, back in November 2011, actually published some examples of the different styles of aurora. So the colors, well, these are the colors that are produced from and the various heights. So the lower colors produced by nitrogen molecules, around 65 to 90 kilometers. Then the middle height colors from the oxygen, atomic oxygen, and particularly the most common being the green, 90 to 150 kilometers. And then the higher colors produced from ionized nitrogen atoms at 1,000 kilometers, so quite a bit higher than the rest. So here's some images. Here's one of mine green, nice structure. And then the genie twist, as I call it, purple green stack, quite common. And then the typical red color wash. So how do we classify these aurora phenomena? So if we're going to observe the aurora over time, we really do need to classify what we're seeing. Now, the first person I could find who did this was Carl Sturmer in 1930. He produced a photographic atlas of auroral forms, and this was the first published system. And in fact, it went on to be the basis of the International Auroral Atlas, published 30 years later. Now, Sturmer was a mathematician and an astronomer. So he wasn't just an amateur observer of auroral form. He actually did professional work there. So he came up with 5 main characteristics based on condition, structure, form, brightness, and color. So were they quietly active or pulsating, smooth or regular structure, discrete, diffuse, etc., etc., etc. Nowadays, there are only 2 main classifications used now: discrete and diffuse. So discrete, can you see, has it got structure? And diffuse, no particular structure, just homogeneous around. So that's the 2 classifications in use today. Now, this brings me on to some so-called new forms, particularly Steve, that's received a lot of press coverage in the last few months. Steve, strong thermal emission velocity enhancement, and it's a, quotes, pinkish optical manifestation of subauroral ionospheric drifts, unquote. Wasn't previously thought to be visible to the naked eye. It thought it was infrared or ultraviolet. However, this was one of the first photographs taken of it. And you can see it's with the aurora, but it's sort of away from it. So it's not actually a part of, it's not actually caused by aurora. Now, this was thought to be a relatively modern phenomena, as it hadn't been photographed before. However, Sturmer had documented it in the 1930s, or it's strongly believed that they've discovered some examples of Steve in that original atlas. So, as I said, Steve is associated with, but is not aurora. It's actually caused by a 25-kilometer wide ribbon of hot plasma at an altitude of about 450 kilometers. So somewhere between the green and the purple aurora, if you remember the color height chart, with a temperature of around 6,000 Kelvin, flowing at a speed of 6 kilometers per second. And outside of this ribbon, or high-level jet stream, if you like, the normal flow is around 10 meters per second. So it's an ultra-fast flow, an ultra-hot flow of plasma. And that's causes this Steve phenomenon. So there's another image of it. And again, above ripples in the aurora, which is yet classified as a new form, but we won't go into that. So I wonder if there was any earlier record, anything earlier than 1930 in Sturmer's atlas. I couldn't find yet any record of Steve-like reports, certainly in the sources mentioned above. However, this is now my current research area, and I'm both trying to observe Steve and also to find historic observations of it. So all I can say is watch this space. Thank you very much.